Hey everyone, and welcome back to the channel. In this video, we'll be learning about marginal revenue. With that said, let's get into it. So let's begin by defining the term marginal revenue. Marginal revenue is the additional income generated from selling one more unit of a good or service. It reflects the change in the total revenue that results from a sale of that extra unit. And in formula terms, it can be expressed as the marginal revenue is equal to the change in total revenue, or delta total revenue, over the change in the quantity sold, or delta quantity sold. Now, if you're familiar with calculus, then you might realize that what we've written on the left is also the same as writing marginal revenue is equal to the derivative of the revenue function with respect to Q, and that's the denotation you see on the right. So again, the marginal revenue is equal to the first derivative of the revenue function with respect to Q. Now let's take a look at what this looks like on a graph. So to begin, we're going to look at the revenue function. So I'm going to draw my axes. I'm going to label them price and quantity, and you'll see that it is an inverted quadratic or an inverted parabola shape. Now you'll notice that there's actually a maximum, and the maximum on this graph is located right here at the vertex of this parabola or this quadratic, and this point would be the maximum revenue. But how do we find this point? Well, this is where we're going to use calculus to find the derivative or the rate of change of this revenue function. So remember that the derivative is simply the rate of change or the slope. And if I'm looking at the slope of something that is not linear, like this parabola, then I'm just going to take the point of tangency. One possible point of tangency is right here. As you can see, the linear line, which represents the marginal revenue, only touches the revenue curve once. So at that specific point, we would be able to calculate the marginal revenue as it relates to the price and quantity being sold from this firm. We could also have a point over here, but we're not concerned with these extra points. We're looking for the point of maximum revenue, which of course occurs right here. And so we're looking at the point of tangency, where you can see that this red line is perfectly flat. Now these red lines all represent the marginal revenue. So if we look at this one right here and we recall our equation for the marginal revenue, it's that the marginal revenue is equal to the derivative of the revenue function with respect to Q. And here we can see that the rate of change, or the slope of the revenue function at this point at the very top, is flat. So we would say that the marginal revenue is 0 because there's no rate of change at this maximum point, hence the flat slope. Now you can see any point to the left-hand side here is going to result in a positive marginal revenue. So I can say that marginal revenue is greater than 0. And for example, looking at the point we looked at earlier, you can see that the marginal revenue is a positive slope, but then any point on the right-hand side is going to have a negative marginal revenue. So marginal revenue is less than 0. And here you can see, using the point we looked at before, that we have a negative slope. We're not concerned with any of these points because we're not maximizing our revenue. The maximum for revenue is going to take place at the maximum of this graph, which is where MR equals 0. So how do we find that? Well, first let's summarize everything we've said so far. In a perfectly competitive market, the firm is a price taker. This means that revenue is a function of the quantity that the firm sells. So if we're given the revenue function, then we can create an equation for the marginal revenue by taking the derivative of the revenue function and setting it equal to 0, and then solving for the optimal quantity. Now this might seem difficult to do, so let's try doing it together. We'll begin by just looking at the generic revenue function, and recall this optimal quantity point at the top is where the marginal revenue equals 0. Well, in order to solve this, I actually need an equation for my revenue. Now I know that the revenue function is quadratic because I can see it's clearly a parabola. So here I'm just going to make up a revenue function, but in your specific case, your revenue function could look different. This will always be given for you, or you'll be given enough information to calculate it on your own. Either way, this is what it looks like. So I have my revenue equation, and it is revenue is equal to 50Q minus 5Q squared. Now you can see that the leading coefficient is negative, hence why the parabola is downward, and I have a maximum instead of a minimum. Once again, the math behind this is that the marginal revenue is equal to the derivative of the revenue function with respect to Q. And if I take the derivative of that revenue function with respect to Q, then I get this next line here. Marginal revenue is equal to 50 minus 10Q. And you might be saying, whoa, I don't know how to go from revenue to marginal revenue. How do I take the derivative? So let me crash course this for you in case you don't actually know the calculus steps behind this. But in order to find the derivative of something, you're going to take the exponent that is applied to the thing that you're taking the derivative with respect to. And in this case, that's Q. I'm going to take that exponent, I'm going to multiply it by the coefficient, and then I will subtract that exponent by 1. So let me show you what that looks like for this 50Q. I'm going to multiply the invisible exponent of 1 that's on that Q times 50, and so 50 times 1. And then I'm going to subtract 1 from that invisible 1, which is going to give me Q to the power of 0. Now remember, anything to the power of 0 is simply 1, so I will have 50 times 1. And as you can see in my marginal revenue equation, that's just 50. Now for the second term, I'm going to have this 2 multiplied by -5, which is going to give me -10. And then I will subtract 1 from the exponent, which is going to give me Q to the 1, which is just Q. So as you can see, if I multiply the exponent by the coefficient, subtract the exponent by 1, this will give me the result of marginal revenue is equal to 50 minus 10Q. Now I know that the optimality condition requires me to set the marginal revenue equal to 0, so that's my next step. I set it equal to 0 and I can now solve for Q. Rearranging this equation, I get 10Q is equal to 50. And then finally, dividing both sides by 10, I get quantity is equal to 5. Now that is my revenue maximizing quantity. But you might be wondering, what about the maximizing price? Even though the firm is a price taker, technically that point at the top of the parabola is a coordinate of quantity and price. So how do we go about calculating the revenue maximizing price? Well, allow me to show you how to do that next. So let me move this all to the side and we're going to solve for the maximizing price. Now recall, the formula for revenue is simply equal to price times quantity. Now I happen to have a full equation for my revenue, which I can set equal to price times quantity, and that's my revenue equation. So I now have price times quantity, which is revenue, is equal to 50Q minus 5Q squared, which is also revenue. So revenue is equal to revenue, of course. Now you might notice there's actually a Q in every single term, so I can cancel all of those Q's out. And once I simplify this, I'll actually get the demand function that was used to calculate this revenue function in the first place. Well, it's actually the inverse demand function, but nonetheless, since I know my Q value, I can substitute it in. And once I do that, I have P equals 50 minus 5 times 5, which is my maximizing quantity. And then I simplify this further to get 50 minus 25. And of course, price must be equal to $25. So I can now plug this in on my graph. And the final thing that I might be asked to do is to now explain what is the actual maximum revenue that this firm can achieve given this revenue function. And that's super simple because once again, revenue is just price times quantity, and I happen to have my price and my quantity on screen. So if revenue is price times quantity, that's going to be 25 times 5, and therefore revenue is equal to 125. And these three values right here are going to be the three values that you're expected to be able to calculate once you know what marginal revenue is and once you set it equal to 0. This is going to give you your maximum revenue. Now in this problem, there's no constraints. If there are constraints, then you could use a different means of calculating, such as the Lagrangian, and we'll cover that in a different video. If you found this video helpful, let us know by liking the video, subscribing to the channel, and of course, let us know in the comment section what sort of economic topics or homework questions you'd like to see us cover in the future. Thanks for watching this video, and we'll catch you in the next.